Okay, so this week we're looking at engineering mathematics, and I thought the best way to actually do this is have a look at engineering exam paper so that we can actually see the expectations of what they're going to do. And let's be honest here, like all the way through the syllabuses and all the way through the documents that we actually work with, this is the only one where you're going to see the math in action, and it's actually being deliberately taught. So I'm just going to zoom in here, and we're going to have a look at this paper. So here, again, I've picked this one. It's aeronautics because it covers a lot of general science and math applications, and we can do the calculations based on that. Again, remembering engineering is about it's about smart design, and it's bringing in the math and science together into this document to actually calculate how things work. So here the question is, we've got an aircraft with a mass of 330 tons. It's climbing at 15 degrees. Each engine produced 510 kilonewtons of thrust, and the aircraft maintains a constant velocity. So here it's actually asking us to complete a space diagram, first of all, and then it's going to ask us down here to determine the induced drag force in this situation. Okay, so for those of you that are interested, to do the diagram, you're actually going to get 2 marks, and if you calculate this out correctly, you can get a maximum of 3. Okay, so let's get onto this space diagram first of all. Actually, before I go there, I'm just going to show you a few of the little tools that I've actually got that I'm going to be using. Obviously, I've got my pens that I'm going to be working with. I have a rule because we're going to need that. I've also got a protractor handy to go, and I have my handy dandy calculator so I can actually crunch some numbers. The other thing that I actually need for this task here is what they say is the HSC formula sheet. So here are all the different formulas that you can use and can ask students in the HSC level, and this is what we're aiming at doing. So this is going to be becoming quite important later on, and I'm going to drag each of these tools in as I need it. Okay, so let's go back to this, and let's start looking at this document and drawing a space diagram. Okay, so a space diagram is basically just taking away all of this information and starting to turn it into a mathematical equation for us. Like here, we can't really do the math. Like we've got the science of what's actually occurring in this diagram, but we want to do it so we can actually start creating it for ourselves. So the first thing I've actually got to do is, we can see here's like a horizon line. Okay, so that's the angle that the plane's taking off in line with the Earth. So here on my book, I'm actually just going to draw that line in now, using the guides of my actual book as well to help me out. So this one here is the horizon, you can say. So I'm just going to call it H for horizon. Now, when it comes to actually engineering mathematics, they say that the weight itself is in the center of the object. So that's what that little black dot is there. So here on my drawing, I'm actually going to put a black dot, which is indication of where the center of all this weight is going to be. Here, my next line I've actually got is the direction that the plane is actually moving on. And I can see, if I come back up to my question, it actually says that it's climbing at 15 degrees. So here, 10, 15, put my dot in, and now I can actually start to draw my lines. So when I'm actually looking at this direction here, this is thrust, and this one here is drag. Okay, so that's what's actually happening to the plane. And what is it thrusting and dragging? It is actually on this section here, which is the one that's coming straight down. Now, if I wanted to do that properly, I should have used my protractor as well, but this here is the actual weight. And you'll have to worry about my spelling later on. Now, the thing with this is here, we've actually got the plane and it's moving in this line. So I want to actually start to draw that here. There's my dot there at 90 degrees. dot down to that center line there. And this is the angle of lift. Now you can start to see here, and if we wanted to, we could start going into calculations where we can start using these different angles. I know that one's at 15 degrees there. Start using these angles to mathematically calculate different directions. Okay? But for this question, it's only asking for a space diagram, and that's what this is. This is actually a space diagram. And like I said, these are used in a lot of situations to move from this real-world ideology to start turning it into a mathematical equation or something that we can actually calculate out. Right, so in this case here, I'm hoping if all work goes well, I'm getting 2 marks, and it is correct. So let's move on to the next part of the question. And the next part of the question actually asks us to determine the induced drag for this situation. Okay, so how much drag is happening here with the plane? New page. Here we go. Here we go. The first thing I actually need to do with this is start to look at what do I actually know. Just zoom in, right? What do I actually know in this situation? So the first thing here, we've actually got, so the plane has a mass of 330 tons, right? Now, we actually, when we're doing calculations in engineering, we actually work in kilos. So this then equals 330, 1, 2, 3. So we're starting to get lots of noughts occurring here, right? And that's in the kg. So that's the first thing we actually know. We know it's also climbing at 15 degrees. So plane climbs at 15 degrees. So we're starting to get an area, like we're starting to understand here. Okay, so I'm looking here. We have thrust, which we have 2 engines, and they're both at 510 kilonewtons. So that is 2 by 510,000, which then equals 1,020,000. Now, like, I'll be honest here, I've actually done this earlier on a calculator, but you'd be pumping these numbers into the calculator to try and actually get it. The other thing that actually says here in the question is that it's at a constant velocity. So that basically means that there's no change to the actual situation, like there's not going to be any updrafts or bird strikes or anything that can actually change the velocity of the plane. So at the moment, we're just assuming that it is constant velocity. So that's an important thing to know. Right. Now, with the engineering stuff, like hopefully with the science, you might have actually heard about this, but we talk about gravity. And in gravity, it equals acceleration. Right, these are some of the engineering terms starting to come through here. And in this case here, acceleration equals 9.8 meters per second. Okay? So now, to make this whole easier, like the whole sum easier, we're actually just going to call this, it's approximately equal to 10. And it just makes our calculations run a little bit smoother. And this is an accepted norm in the situation. Right, now that we've got all of this, we can actually start looking at doing the calculations. I might just zoom out a little bit here so you can see how the whole thing is going to come together. Right, formula sheet here. We're actually going to be talking about moments, and we're looking here at force equals mass by acceleration. Okay, so that's the main formula that we're actually going to use. So, here we go. So, force equals, let me just write this out so it's easy to understand. Force equals mass by acceleration, which equals weight equals mass by acceleration. I don't want you getting too bogged down here, but like if you have a look at all of this, the engineering jokes and things that are out there is that we're constantly getting weight wrong because we don't consider acceleration. If you're really interested, we'll come back to that later on. But in this case here, generally speaking, in engineering, weight is force and it's mass by acceleration. Come back later to that if you really want to know more. Just put some comments up online and we can talk about it if you like. Okay, so here we actually have a mass which is 330,123 by acceleration, which is 10, which then means we've actually got 3,300,000 newtons. Okay, so we're actually calculating newtons. So that's the weight of the plane. Now here we've actually got to move to, again, this idea that thrust equals drag plus weight. Okay. So then we can actually have, if we start doing the actual calculations, we can actually have thrust, oh, what terrible spelling, thrust plus drag equals weight, therefore drag equals thrust minus weight. Okay. So hopefully that was quite simple in that process, but now we can actually start putting all of these numbers in to actually get this scenario out. Now, the only thing that we've actually, so the drag is what we're trying to find. We now know that thrust here, thrust up here equals 1,020,000, and it's minus the weight, which is 330,000 kilos. However, because the plane is actually taking off on that angle, and I'm coming back to this drawing here now, because the plane is actually taking off on this angle, this weight is actually changing because of this. So we now actually need to bring in the sine rule to calculate that triangle. So here it's actually sine the angle, which is 15 degrees. So this now equals 1 minus 330,000 by 0.2588. Now, if you're wondering where I've gotten that number from, we'll just have a quick look here, turn the calculator on. It's sine 15 degrees equals 25881, so it's rounded up to that, and that's how we actually get the number. So we have 1020000, which equals minus 854040, which equals 165,960 newtons, and then that makes it approximately 166 kilonewtons if we round it up. So therefore, the drag on the plane equals 166 kilonewtons. So I hope you can see how the engineering mathematics actually works, and this is what we're actually aspiring to do in this course. So yeah, feel free to take this example back to your classes and teach them how to do it. Thanks for listening. Talk to you soon.